We saw in the last example that although instance variables are very useful, we had to repeat a lot of nearly identical code to move multiple ships around. That's where methods come in. Methods are functions that are defined inside a class. They're also sometimes called member functions. And the way to define a method is to say public or private. We'll discuss the distinction shortly. Give the return type, like it returns a string or an int. You can say void if it doesn't return anything at all. Give the name of the method. Give the argument to the method in parentheses, and then define the body of the method. And in Java, that's the only way to define a method or a member function. There's no such thing as a global function, and there's no such concept as stubbing out a method first and then giving the definition later. You just define it inside a class. Now, the distinction between public and private that we'll see later is an important one, and we'll discuss that distinction shortly when we give an example with ships. Here's a quick example. Suppose that you have a person, and you've defined two instance variables for the person that are of type string, first name and last name. And now you want to find out what the full name of the person is without having to repeat the code. So your definition of the full name should be reusable. You shouldn't have to repeat the calculation for computing the full name. If you come from a procedural language, you might think of a reasonably good idea, which is define a global function that you pass in a person and you get out that person's full name. That's not a bad idea. And you could try something similar, not with a global function, but still with a function in Java. But you can do better. The full name is an intrinsic property of a person. In other words, inside the person class, you already have all the information you need to calculate the full name. So by putting the full name method or the get full name method inside of the class definition, you simplify things. You ask for a particular person's full name. You don't have to pass in any arguments at all. And the get full name method can calculate what the full name is based on the instance variables of the same class. So if you come from a procedural language, you're always tempted to write methods that you pass objects to. But instead, you frequently write methods on classes that you call on objects. And so I said earlier that three of the high-level characteristics of objects are state, behavior, and identity. State was provided by instance variables. Behavior is provided by methods. All right, let's look at an example that uses methods. As before, I'll skim through the example quite quickly the first time to give you the basic idea, then come back and look at the features in more detail. So I have a ship class, as we saw before, and I have added a few methods to it. In particular, I can instruct a ship to move itself, update its x and y position based on the speed and direction in which it's going. And I can ask a ship to print out its current location. So then in my test routine, after I make a ship, I ask it to move itself by using the variable name a dot, the method name, and then in parentheses any arguments that the method takes, in this case none. And I can ask a ship to print out its location by using a variable name a dot, the method name, and then in parentheses any arguments that the method might take. And when I run it, I get the same basic behavior as I did before, but now my code is much more reusable. I haven't repeated myself. In particular, I haven't repeated the calculations for updating the x and y position for the two separate ships. I've shared or I've reused that code. All right, so that's the basic idea, but let's look at it now in more detail. The first point is that the place that you define a method, a member function, is inside of a class between the curly braces, just as the place you define an instance variable is inside a class between the curly braces. The next point is that in Java, you can give default values to instance variables without having to define a constructor. Now we'll see what constructors are later, and they're quite useful, but the point here is that if I instantiate a ship, if I call new on ship, and I don't say what the x, y, speed, direction, or name is, I know ahead of time what the values are. Now, there are defaults. If you don't even bother to say what the default value is, for numbers, it's automatically 0, and for objects types like string, it's automatically null. But for the ones I've highlighted here in yellow, would not have been the defaults unless I had said so. So in Java, unlike some other object-oriented programming languages, it's not necessary to define a constructor in order to give default values to fields. You can list them after an equal sign right when you declare the instance variables. All right, then the next point is that I defined a method called print location. Print out the location of a ship. This is such a common thing that Java has a standard way of doing it, a method called toString. So really, what I should have done is given a toString method and then printed the instance of the ship, and we'll talk about how to do that in the third lecture on object-oriented programming and give some specific examples. And finally, perhaps the most important thing of this entire section is the distinction between private and public. Now, there's two questions when you look at this distinction. One is the syntax. What does it do? And the other is the semantics. Why? Why are you doing this? What does it mean? The syntax question is easy. The semantic question is much more difficult. So first, let's look at the syntax question, which is quite easy. What does it mean when you say public versus private for a method? To answer that question, you have to look at the calling code. The calling code, which is in a separate class, calls move. It can do that because move is declared public. It calls print location. It can do that because print location is declared public. But it would not be possible for this code in a separate class to call degrees to radians. If it tried, the code wouldn't even compile, and you get an error message saying there is no publicly accessible method called degrees to radians that takes a double as an argument. So what is easy to answer? If you declare it private, only code inside of the class definition can call it. If you declare it public, code inside or code outside can call it. All right, that's the easy question. What? The hard question is why? In particular, why should I make degrees to radians be private? After all, I claimed earlier that the main goal of object-oriented programming is to avoid needing to repeat identical or nearly identical code, not repeating yourself. By making this private, I've prevented other classes from using my method, and if they need to compute degrees to radians, they are going to have to repeat the code. Haven't I just broken the main principle of object-oriented programming? Well, that's true in a sense, but there's another goal of object-oriented programming. The first primary goal is don't repeat yourself. Save yourself from having to write identical or nearly identical code. But the second goal of object-oriented programming is limit the ripple effect. Make it so that minor inconsequential changes to the internal details of a class doesn't require changes to all the classes that use it, and then all the classes that use those, and all the classes that use those, and all the classes that use those, and pretty soon changes have rippled throughout your entire program when you've only made a small inconsequential change. So the question is degrees to radians something that a ship intrinsically does or intrinsically knows about? And the answer is no. Degrees to radians is just an internal utility that I created because the Java trig functions like sine and cosine use radians, and I, in my application, want to use degrees. So I just create a method, I call it degrees to radians, and I don't have to tell anybody else about it. I made it private. Not only can I make it private, I absolutely, positively should make it private. Because if I make this public, and then later on I change my mind and I move it someplace else, which I very reasonably could because it's not something that ships do, then all the other classes that call ship might now be broken. Now move is different. Move is something that a ship does. If I'm going to take it out and say ships can no longer move around, there are buoys or something, then I fundamentally change the way that ships behave, and I expect the calling code to need a change. But degrees to radians was just kind of a local helper function that I use to make my own code simpler. Nobody else should know about it, and most importantly, if I change my mind, I don't need to tell anybody. So the goal of private methods is to let you change the way that function works or take it out entirely and not have to change any of the calling code. In fact, the general principle is declare everything private unless you have a specific reason to do otherwise. So declare degrees to radians private, declare move private, declare print location private. But then you say, well, wait, hang on a second. Move is something that I need to instruct a ship to do from the outside. All right, I change my mind and make it public. oh, print location, that's something that I do from the outside to query the current location of a ship. Oh, I'll make that public. But your first instinct is to make it private and make it only public if you need to. Don't do it the other way around. Don't have your first instinct be to make the methods public and make them private only if you need to. All right, so degrees to radians should be private if it's inside the ship class. But what if you have lots and lots of places in your application where you need to convert degrees to radians? That's a very reasonable possibility. What do? Can you make it public? Well, yes, you can make it public, but not in the ship class. So here's how you can fix it. Use a static method. All right, so I made the degrees to radians method private, as I should have, but then later on I discovered, there's lots of other classes that need to convert degrees to radians. I want to make my code reusable. So I go to my package and I make a new class, and I call it something that's not specific to ships. Maybe I call it math utils. And I go back to the ship class. I cut out the degrees to radians method. I paste it into math utils. I change it not only from private to public, but also I add in the word static. And then I go back to ship class and I add in the class name in front. So a static method is a method that you can call without ever instantiating the class to which it belongs. So I don't say call new on math utils. I just say math utils, the class name dot degrees to radians. Another way of looking at it is degrees to radians can be a static method because its return value is entirely dependent on what you passed in. That was not true with move. Internally, it used some of the state of the class, the x and y variables. That was not true with print location. Internally, it used some of the internal state of the class, the x and y variables. But in the case of degrees to radians, the output is totally determined by the input. That doesn't mean that you must make it a static method. That means it's a candidate to be a static method. So you start off with it as a normal private method. Then you find that other classes need to use it as well. Take it out of your original class, move it to a utility class, declare it public static.